4 hours ago, something happened that should not be possible. At exactly 14 UTC on March 2nd, 2026, the quiet rules that govern our solar system were challenged in a way no textbook can explain. I need you to focus carefully, because what I am about to describe has virtually zero probability of being a natural event. NASA's Deep Space Network and the Goldstone Radar Facility detected a separation from the object we have been casually calling Ceni Atlas. For months, it was labeled a comet, just another icy traveler passing through the dark. Nothing special, nothing threatening. But the data now sitting on screens inside Mission Control has forced a complete reclassification of what we are dealing with. Imagine watching a car moving down a highway. Now imagine a smaller piece suddenly detaching from that car. In nature, when debris breaks off, physics is clear. The detached fragment drifts away, losing energy, spinning unpredictably, obeying the law of conservation of momentum. That principle is not flexible, it is fundamental. But what occurred today did not follow that rule. When a perfectly shaped metallic sphere separated from Atlas, something we are now referring to as object beta, it did not drift into space. It accelerated in the vacuum of space without any visible exhaust plume and without any chemical propulsion detectable by infrared sensors. The sphere instantly increased its velocity by 12 kilometers per second. That is not passive motion, that is controlled thrust. I have spent years studying theoretical physics, analyzing the behavior of natural objects under gravitational forces. I reviewed data from the Jet Propulsion Laboratory and cross-checked it against telemetry from the European Space Agency's Gaia system. The conclusion is deeply unsettling. Rocks do not execute high-G maneuvers. Comets do not decide to change course. Right now, this sphere is on a trajectory that intersects Earth's high orbit. It is not passing by us. It is arriving. Inside government facilities, emergency briefings are already underway. When analysts projected its path, the precision of the trajectory was unmistakable. It is heading toward the Earth-Sun L1 Lagrange point, a gravitational balance location where an object can maintain a constant, uninterrupted view of our planet. This is not a collision path, it is an observation position. The mass readings add another layer of concern. Based on the gravitational disturbance measured during separation, this small sphere has a density that does not align with any normal planetary material. It is heavier than lead, yet it moves with unnatural ease. We are no longer debating whether Atlas is unusual. That discussion ended the moment object beta accelerated. The real question now is simple and unsettling. What is inside that sphere, and why is it coming here so quickly? To understand how extraordinary this is, we have to examine the timeline. At 13:55 UTC, 5 minutes before separation, Atlas was traveling through the inner solar system at 34 kilometers per second relative to the Sunday. Goldstone radar data showed a typical tumbling body. It looked irregular, exactly what we expect from a comet. Then at 14 UTC, the radar cross-section changed instantly. And that is where the impossible part begins. Usually, when a comet breaks apart, it is chaotic. Gas expands, ice sublimates, debris scatters violently. We see dust clouds and explosive fragmentation. That is entropy at work. But at precisely 14 UTC, Atlas did not explode. It opened. It opened in a way that forces us to reconsider every model of cometary physics ever written. The Goldstone radar data does not show cracking rock or explosive debris. It shows controlled motion. A section of the main body shifted aside with mechanical precision, and from within that shifting mass, the sphere emerged. There was no dust plume, no scattered fragments, no expanding cloud of gas. The object slid outward smoothly, as if released by design rather than torn free by stress. Pause for a moment and consider what that implies. Nature is chaotic. Mechanical systems are precise. What we observed was precision. In science, one observation is never enough. We demand independent confirmation, and within minutes it arrived. NASA's Deep Space Network recorded a clear Doppler shift. The signal frequencies separated, indicating two distinct objects moving at slightly different velocities. At the same time, the European Space Agency's Gaia telescope detected a measurable wobble in the remaining body of Atlas, confirming that a significant mass had departed and altered its center of gravity. Then came the most critical validation. The James Webb Space Telescope, already tracking the coordinates, captured the event using its near-infrared camera. It did not simply confirm separation, it detected something far stranger. When rocks fracture in space, friction generates heat. The detached fragments should glow in infrared wavelengths. It should appear warmer than the surrounding vacuum. Instead, the sphere registered near absolute zero immediately after separation. It was colder than the background of space itself. That detail cannot be ignored. Energy release always produces heat. The only way to avoid a thermal spike is through a frictionless mechanism or through an internal system capable of absorbing and masking that heat instantly. Either scenario points away from natural processes. The separation appears magnetic or mechanically controlled. The main body of Atlas behaves less like a comet and more like a carrier structure. The sphere was not ejected, it was deployed. Moments later, Goldstone radar returned another anomaly. Natural asteroids scatter radar signals unevenly because their surfaces are rough and irregular. The return echo from object beta was different. It came back clean, coherent, and sharply defined. That happens only when radar reflects from a surface that is nearly perfectly smooth. The sphere's geometry is mathematically precise, polished to a tolerance within fractions of a millimeter. It reflects radio waves with mirror-like clarity. Then came another change. 10 minutes after detachment, the sphere stopped tumbling. Every natural object in space rotates unpredictably due to collisions and gravitational forces. This one stabilized. Its rotation dampened and locked onto a single axis. Even more striking, that axis aligned directly toward Earth with a precision of 0.04 degrees. It is not facing the Sunday. It is not oriented randomly. It is pointed at us. By this point, the evidence was overwhelming. We were no longer looking at debris. Debris does not cool itself to near absolute zero. It does not present a flawless radar cross-section. It does not stabilize its spin deliberately. What we are witnessing resembles activation. A system has awakened. 15 minutes after separation, at 14:15 UTC, the next event forced engineers at the Jet Propulsion Laboratory to recheck their instruments for error. The sphere accelerated again. It moved from 34 kilometers per second to 46 kilometers per second in just 18 seconds. That is a massive increase in velocity over a remarkably short interval. The energy required for that change exceeds what our largest rockets could generate without enormous fuel reserves. Yet no exhaust plume appeared. No thermal signature was detected. It simply increased speed as if propulsion laws did not apply. Newton's laws have governed our understanding of motion for centuries. To accelerate, a force must be applied. To move forward, mass must be expelled backward. That is the foundation of rocket science. But here, there was no expelled mass. no visible reaction. The sphere accelerated in silence. It accelerated in silence, and that silence is the most disturbing detail of all. Every propulsion system we have ever built leaves a signature. Chemical rockets burn fuel and create bright plumes. Ion drives emit charged particles. Even nuclear propulsion generates heat that can be detected across vast distances. The James Webb Space Telescope was watching continuously during the velocity jump, and its infrared instruments reported nothing. No plume, no exhaust, no thermal spike. The sphere increased its speed as if it were pulling itself forward without pushing anything back. That defies Newton's third law. For every action, there must be an equal and opposite reaction. Yet here, there was motion without visible reaction. Physicists have long theorized about propulsion systems that do not rely on propellant. Concepts like warp metrics and space-time manipulation appear in advanced equations, but they have always remained theoretical. We have never observed a real object demonstrating such behavior until now, and the acceleration was only the beginning. At 1417 UTC, 2 minutes after reaching 46 kilometers per second, the sphere performed what engineers call a vector correction, but the simplicity of that term hides the severity of the maneuver. Traveling at roughly 100,000 miles per hour, the object shifted its trajectory by 18 degrees. To understand why that is extraordinary, picture driving at extreme highway speed and attempting a sharp turn without slowing down. Inertia demands resistance. Structural limits impose constraints. Yet the sphere did not slow, bank, or arc gradually. It altered its path cleanly, instantly. The forces involved in such a turn would exceed 400 Gs. A human pilot loses consciousness at around 9 Gs. Modern fighter jets struggle beyond 20 Gs. Advanced missiles fail structurally near 100 Gs. At 400 Gs, most materials would deform or shatter. A natural rock would fragment into dust under that stress. Radar data shows no deformation, no instability. The sphere remained perfectly intact. That durability reveals two possibilities. First, the material composition must exceed diamond in tensile strength. Second, and perhaps more significant, the object may be counteracting inertia internally. If there is any delicate system or biological entity inside, it would be destroyed by those forces unless gravity itself is being manipulated to cancel acceleration effects. That suggests inertial dampening, a technology that has only existed in theoretical discussions. When analysts projected the new trajectory after that maneuver, the pattern became clear. The object is not wandering randomly. Its path aligns precisely with the Earth-Sun L1 Lagrange point. This is a gravitational equilibrium location approximately 1.5 million kilometers from Earth. Satellites placed there remain stable, balanced between the gravitational pull of the Sun and Earth. From L1, an object has an uninterrupted view of our planet's daylight hemisphere at all times. It is the ideal observation post. Comets do not aim for Lagrange points. Natural bodies do not execute controlled insertion paths into stable gravitational positions. The maneuver we observed resembles a calculated orbital adjustment similar to a spacecraft performing an insertion burn to reach a parking orbit. The sphere is not drifting into L1, it is targeting it. As troubling as the maneuvering is, the mass calculations add another layer of complexity. Using the gravitational perturbation measured during separation, scientists estimated the sphere's mass. It is approximately 10 meters in diameter, about the size of a small building. If composed of typical rock, it would weigh around 1,500 tons. If solid iron, perhaps 4,000 tons. The calculations show something far beyond that. The sphere weighs approximately 400,000 tons. That mass compressed into such a small volume implies extraordinary density comparable to material found in the remnants of collapsed stars. Yet, despite that immense mass, the object accelerates and turns as if inertia barely affects it. Yet, despite that immense mass, the object accelerates and turns as if inertia barely affects it. That contradiction sits at the center of this entire event. An object that heavy should resist rapid changes in velocity. It should behave like a massive anchor in space, slow to respond and predictable under gravitational influence. Instead, it moves with precision and ease, as if its own mass is not a limitation but a tool. The only explanation that fits the data is that the sphere is manipulating gravity itself, creating localized distortions in space-time to move without traditional propulsion. We are not observing conventional mechanics. We are observing controlled relativity. As the sphere continued its approach toward the L1 position, another wave of analysis began. Spectrometers at the Keck Observatory in Hawaii and the James Webb Space Telescope were directed toward the object at 1530 UTC. Spectroscopy allows scientists to determine an object's composition by examining how it absorbs and reflects light. Every element leaves a distinct signature. Hydrogen produces one pattern, iron produces another. It is one of the most reliable tools in astronomy. When the results returned, researchers initially suspected calibration errors. The spectral lines were exceptionally clean. Natural asteroids typically show mixed signals due to dust, ice, and varied mineral content. This spectrum was nearly perfect, indicating a purity of 99.999%. The dominant element identified was osmium, the densest naturally occurring element known on Earth. Osmium is extremely heavy, highly reflective, and difficult to process due to its brittleness. On our planet, it is used only in small quantities for specialized applications. Yet this sphere appears to consist of a solid shell of refined osmium, roughly 10 meters in diameter. The scale of that is staggering. To accumulate and refine 400,000 tons of osmium would require industrial capability far beyond anything available on Earth. The total accessible osmium in our crust is significantly less than that amount. Manufacturing such a structure would require harvesting resources on a solar system scale. That alone suggests intentional design. But osmium is not the only element present. Spectral analysis revealed traces of technetium woven into the metallic lattice. Technetium does not occur naturally in stable form. It is produced in supernovae or within nuclear reactors. Its presence is a clear indicator of artificial synthesis. Finding technetium embedded within the sphere is equivalent to discovering manufactured plastic on an untouched planetary surface. It is a signature of deliberate creation. In condensed matter physics, there are theoretical discussions about combining ultra-dense metals with specific isotopes to produce materials capable of extreme reflectivity. Such a surface would not only reflect visible light, but also electromagnetic radiation and possibly gravitational waves. The measured albedo of the sphere is 0.99. For comparison, Earth reflects about 30% of sunlight, and the Moon reflects roughly 12%. This object reflects 99%. To an observer, it would appear almost invisible, blending perfectly with its surroundings. As the sphere settled into the L1 region, radar returns began to weaken dramatically. Within minutes, reflections ceased almost entirely. The object effectively vanished from active detection systems. We can still infer its presence through gravitational measurements, but visually and electromagnetically, it has entered a stealth state. It has parked, stabilized, and concealed itself. As of 18 UTC, we have a 400,000-ton sphere positioned precisely at L1, maintaining a constant view of Earth. It is invisible to conventional sensors, yet detectable through subtle gravitational disturbances. It is silent and cold. But moments ago, the Green Bank telescope detected one final anomaly that shifts this from observation to confirmation. A single compressed burst of data was recorded, not in radio frequencies, but in neutrinos. A single compressed burst of data was recorded, not in radio frequencies, but in neutrinos. That detail alone changes everything. Neutrinos are subatomic particles that pass through ordinary matter almost without interaction. Billions of them move through your body every second without leaving a trace. They are incredibly difficult to detect and even harder to generate in a focused beam. On Earth, producing controlled neutrino emissions requires massive particle accelerators and enormous energy output. Yet at 1755 UTC, the Green Bank telescope registered a short, directed neutrino burst originating from the exact position of the sphere at L1. The beam was narrow and deliberate. It was not random radiation. It was aimed away from Earth, away from the Sun, and away from any known artificial satellite. Its direction aligned precisely with the star system located in the Cygnus constellation, approximately 1,400 light-years from our planet. That is not coincidence. The precision of the alignment suggests targeting. Consider what that means. The sphere did not attempt communication with NASA. It did not broadcast toward our deep space antennas. It did not transmit a signal toward the United Nations or any known listening array on Earth. It ignored us entirely. Instead, it sent a tightly compressed neutrino message into deep space. Neutrinos are ideal for interstellar communication because they are nearly impossible to block or intercept. They travel straight through stars, planets, and dust clouds without scattering. If you want to send a message across the galaxy without interference, neutrinos are the most reliable medium. The timing is also critical. The burst occurred only after the sphere stabilized in its L1 orbit and activated stealth. It arrived, positioned itself, concealed its presence, and then transmitted. That sequence resembles a reconnaissance protocol: deploy, observe, confirm, report. Physicists reviewing the data are cautious, but direct. The propulsion behavior indicates advanced control over gravity or inertia. The composition indicates industrial-scale engineering beyond terrestrial capacity. The trajectory indicates a deliberate parking maneuver in an optimal observation zone, and the neutrino transmission indicates outbound communication to a distant origin point. Each individual anomaly could be debated in isolation. Together, they form a coherent pattern. The remaining question concerns intent. What exactly did the burst contain? The data compression suggests structured information rather than random noise. It likely carried a compact dataset, possibly observational telemetry collected during approach. If this sphere is a probe, its mission may have been straightforward: confirm the presence of technological activity on Earth and relay that confirmation to its point of origin. The sphere did not arrive quietly and depart. It did not pass by on a hyperbolic trajectory like previous interstellar objects. It entered our solar system attached to a larger carrier body, deployed itself with mechanical precision, navigated directly to a gravitational vantage point, and transmitted outward. That sequence resembles a scout verifying a target. Astronomers at the European Southern Observatory have begun long-duration monitoring of the Cygnus region to search for any correlated response. If the source of that burst replies, we may observe a return neutrino pattern in decades, perhaps centuries, depending on distance and travel time. But the sphere itself remains here, stationary at L1. Gravitational sensors continue to register subtle disturbances consistent with its calculated mass. It has not moved since stabilizing. It has not emitted additional detectable signals. It remains silent, cold, and nearly invisible. The machine has completed its initial sequence, and now we face the final implication. If this object is a scout, then scouts precede something larger. If this object is a scout, then scouts precede something larger. That is not speculation born from fear. It is a pattern observed throughout human history and in every strategic framework we understand. Exploration probes are sent ahead to gather data. Reconnaissance units verify conditions before greater commitments are made. The sequence we have documented over the past several hours follows that logic precisely. A carrier body entered our solar system quietly. It deployed a secondary object with mechanical accuracy. That object, maneuvered with propulsion methods beyond known technology, positioned itself in a gravitationally stable observation point, concealed its presence, and transmitted a report away from Earth. The pattern is structured, intentional, and complete. We must separate emotion from analysis. The sphere has not attacked. It has not interfered with satellites. It has not disrupted communication networks or altered Earth's orbit. Its behavior so far indicates observation, not aggression. But observation alone carries profound implications. It confirms that we have been detected, not by accident, not by passive signal leakage, but by an entity capable of crossing interstellar distances and manipulating gravity with precision. The energy requirements for such travel are immense. The engineering required to refine and assemble 400,000 tons of osmium infused with artificial isotopes suggests access to stellar-scale resources. That level of industry implies a civilization significantly older or more advanced than our own. If they can harvest material on that scale, they can likely perform feats we cannot yet imagine. Yet the sphere did not deploy weapons or attempt communication. It simply verified and reported. Some physicists argue that the propulsion method observed may not violate physics at all, but instead exploits aspects of general relativity we have yet to harness. If the object can create localized space-time curvature, it could effectively fall in a direction of its choosing, eliminating the need for traditional thrust. That would explain the silent acceleration and high-G maneuver without structural damage. It would also mean gravity is not merely a force acting upon it, but a field it can control. The stealth properties reinforce this assessment. A surface reflecting 99% of electromagnetic radiation renders the object nearly undetectable. Combined with thermal suppression to near absolute zero, it becomes invisible against the cosmic background. Only its gravitational signature betrays its presence. That level of concealment suggests caution. It did not wish to be easily observed while it conducted its mission. Now the sphere sits 1.5 million kilometers away, fixed in the L1 Lagrange point. From that vantage, it has an uninterrupted view of Earth's illuminated hemisphere. Every city light, every atmospheric fluctuation, every radio transmission, every launch is within its observational reach. It can watch weather systems form, satellites move, and even subtle changes in electromagnetic activity. It is positioned not for a brief glance, but for long-term surveillance. We do not know whether additional probes are already en route. We do not know whether the signal it sent will trigger a response centuries from now, or whether this was a final confirmation before a larger presence arrives sooner than we expect. What we do know is that the laws we assumed were fixed have been challenged by direct observation. Something reached into our solar system, demonstrated control over gravity, and declared our existence to a distant star. The universe has just become quieter and louder at the same time. Quieter because we are listening more carefully than ever before. Louder because we now know someone else may be listening too. If you want to stay informed as this story develops and follow every verified update as the data continues to unfold, make sure you subscribe, turn on notifications, and stay with us.